So 9.5, we're going to be graphing tangent and cotangent. Today we're just going to focus on tangent. Tomorrow we'll do cotangent. So everything I talk about today only involves tangent. So we have our parent functions of tangent, which is just our basic y is equal to tangent of x. These are all of our properties for just the basic tangent x graph. So because tangent is equal to sine over cosine, our graph is undefined for x values in which cosine of x is equal to 0. So remember, we can't have 0 in the denominator of a fraction. So our graph is undefined anytime cosine of x is equal to 0. And when our graph is undefined, we have these nice little asymptotes on our graph. So you can think of asymptotes as like brick walls. Our graph will get really, really close to this asymptote, but it'll never touch. So all of these dotted lines are asymptotes. For our tangent graph, which is a little bit different than sine and cosine, instead of our period for sine and cosine being 2 pi, our tangent graph, our period is pi. So that's just one difference. Instead of dividing 2 pi by b, we're going to just be dividing pi by b for tangent. And then to find our asymptotes, we always just take our period and divide it by 2. So if we see here, our asymptote is at pi over 2 and negative pi over 2. That's because we go pi over 2 in the right direction and pi over 2 in the left direction. And when you add those together, you get your whole period, pi. So whatever your period is, divide it by 2, those will be your asymptotes. So some characteristics of our tangent graph. The domain y is equal to tangent of x is all real numbers except odd multiples of pi over 2. So all real numbers except odd multiples of pi over 2. And when we say odd multiples, that's where our asymptotes are. So here we have pi over 2, which is technically just like 1 pi over 2. 1 is an odd number. Next we have our asymptote at 3 pi over 2. 3 is an odd number. Our next asymptote would be over here somewhere. What would this asymptote be at? Our asymptotes are at odd multiples of pi over 2. Is 6 an odd number? 5 pi over 2. What would our next one be at? 7 pi over 2. So odd multiples of pi over 2. And then our graph just continues that same little snake-like shape all the way through. Keeps repeating and repeating and repeating. The range of each function is all real numbers. That's because for range, we look at y values. We go down to negative infinity, up to positive infinity, so we have all real numbers. And we do not have a maximum or minimum for these graphs. And then again, the period of each graph is pi. So sometimes we'll have a number being multiplied out front of the tangent or out front of the x. So we have our a and b just like we did for sine and cosine. Our period is pi divided by b. And the vertical asymptotes are at odd multiples of pi divided by 2b. So to find our asymptotes, we just take the period and divide it by 2. Because our period is like that whole length, but we're cutting it in half to figure out what that asymptote part is. So we just take our period, divide it by 2. So that is for tangent graphs. Here is an example of a tangent graph. For tangents, we're just going to have 3 key points. We have one here, one here, one here. We don't have an amplitude here like we did in sine and cosine. But the A does tell us how much we go up and how much we go down for our key points. So we take our period and divide it by 2 to find our asymptote. Then we take our asymptote and divide it by 2 to find this number here. This number and our A makes a little box. We put a point at the middle of our box, we put a point at the upper right-hand corner and the lower right-hand corner, and then we just snake our graph through there. So that's going to be how we graph. We'll go over more examples. I know it doesn't make a lot of sense just walking you through it, but it'll start to make sense when we do examples. So graph 1 period of g of x is equal to 2 tangent 3x. So we want our A and our B. What's our A? 2. And our B? 3. To find our period, it is pi divided by B. What's our B? 3. So pi divided by 3. To find our asymptotes, we take our period divided by 2. So our period was pi over 3 divided by 2. If you divide something by 2, it's the same thing as multiplying it by 1/2. So, or we could just divide it by 2, keep change, flip. So change to multiplication, flip the fraction on the bottom. We get pi over 6. So that's where our asymptote's going to be. Let's go ahead and draw it so we can see. We have our graph here. Our asymptote, we're going to go to the right, pi over 6, and we go to the left, negative pi over 6. Our asymptotes get a dotted line. Those are our brick walls that we can't cross. And the next thing we want to find is where our key points are going to be. So we take our asymptote and divide that by 2. So our asymptote was pi over 6 divided by 2. Dividing by 2 is the same thing as multiplying by 1/2. So it's pi over 6 times 1/2. Pi over 12. Good job. So we're going to go to the right, pi over 12, and to the left, negative pi over 12. Our A tells us how much we go up to make that little box. So what was our A? 2. So we're going to go up 2 and down 2. So now we have this imaginary box in here. We want to put a point at the top right corner of our box, at the middle at 0, 0, and at the bottom right corner of our box. Once we have those 3 points, our graph just snakes through it there. It gets really, really close to the asymptotes, but it never crosses. Now you don't have to draw the box. The box is just there to show you where we put our points. If it helps you to draw it, you can draw it and erase it, but just drawing it to show you. So looking at number 1, first thing we want to do is list our A and B. What's our A? 1. What's our B? 2. So we use our B to help us find our period. Period is what divided by B? Pi divided by B. So pi divided by 2. Can't simplify that, so it's just pi over 2. How do we find our asymptotes? Period divided by 2. So pi over 2 divided by 2. Keep change flip. We get pi over 4. So let's go ahead and put our asymptotes on our graph. We go to the right, pi over 4. To the left, negative pi over 4. And we draw our dotted lines through there. Next thing we want is our key points. How do we find our key points? Asymptote divided by 2. So keep, change, flip. We have pi over 8. So we go pi over 8 and negative pi over 8. How much should we go up and down on our y-axis? What's our A is 1, so we go up 1 and down 1. So now we just made this little box in the middle here. We put a point in the middle, point in our upper right-hand corner, point in our lower left-hand corner. And then we just snake our graph through here. All right, number 4. So what's our A? 5, and what's our B? Pi. So first thing we want to do is find our period. How do we find the period? Pi divided by B, which is pi over pi. What does pi over pi simplify to? 1. So now how do we find the asymptotes? 1 divided by 2, which is 1/2. So we're going to go to the right 1/2 and to the left 1/2. Negative 1/2 to the left. Put our dotted lines through there. All right, what do we do next? Key points. How do we find our key points? 1/2 divided by 2, which is 1/4. So we keep, change, flip. We get 1/4. So we're going to go to the right 1/4, to the left negative 1/4. What should we do next? We've got to use our A. So our A tells us how much we go up and how much we go down. So what's our A? 5. So we go up 1, 2, 3, 4, 5. And we go down 1, 2, 3, 4, 5. What's next? Dot in the middle. Awesome. And then we put our graph. I missed the dot. There we go. That's our graph. So just be careful when drawing your graph. It's not a straight line. It's got to have like that S type of shape, that like snake-like shape. It's got to have a little bit of curve. Here you can't see much of a curve because we go up so quick, but you get the idea.